Welcome to Wireless Future. My name is Eric Larsson and I'm here as always with my colleague Emil Björnsson. Hello Emil.
Hello, how are you today?
Good Emil, how are you?
I'm great. It's good to talk to you as always.
As always, recording again, Emil.
Yes.
So I heard Emil that you like to read books.
Occasionally, mainly at work. So I read so much at work.
Yeah, mostly at work. I mean, me too. But I mean, and the funny thing with books is that at the surface, when you open them, a lot of them just look alike, right? But really, some of them are really great tools, I think, for keeping you up at night. Whereas some of them are tools for really getting you to sleep at night. So, so today we're going to talk about books, or in fact, in singular, a book that you have read, the 6G Manifesto.
Yes.
And this is a book that came out last October, I believe. Who is the author?
William Webb, who is a independent consultant today, but many people might know him from his time at Ofcom, the UK regulator, where he was the director of technology resources and worked a lot with spectrum policy for many years.
Okay, this is Ofcom in the United Kingdom.
Yes.
Sure, right. So what is this book? What is this? I mean, from the title, it sounds like an interesting thesis as the 6G Manifesto. So what is the punchline?
Right. So the punchline, someone told me that if you want to know if a book is good or not, you should start reading it from the end. And so if one does that, then the last sentence is 6G should be for the many and not the few. 6G
should be for the many, not for the few. Well, it sounds like an agreeable statement in a way, I would think. Not too controversial, I suppose.
Right. But the book spends a lot of time trying to make the point that it should be controversial in the way that many of the predominant 6G visions focus on entirely different things, in the author's opinion. And he then makes a case for that ubiquitous connectivity, or one can call it different things, that there should be sufficient wireless connectivity available everywhere at any time for everyone. It should be something that we should really focus on in 6G.
Yes, ubiquitous connectivity. I mean, that sounds like music in my ears, and that sounds almost like the title of a paper that we gave, like it's probably 10 years ago by now, on uniform quality of service using distributed or cell-free massive MIMO. I mean, the whole idea is to provide ubiquitous coverage to everybody, so that there's no border between cells or cell edges where you have coverage issues. So is that what he's after here with in the book?
Yeah, that was what I was thinking as well, because I catched on that train and trying to deliver a physical layer that can provide good connectivity everywhere, just as you did maybe a few years later. But this is actually not the approach that Webb is suggesting, but he is approaching this at a different layer, one can say, of the protocol stack.
So it's a different layer. Okay, so maybe we should. I mean, you said start from the end, but how about we start from the beginning?
Yes.
So, do you wanna maybe we could summarize what is the approach then? If it's not cell-free or distributed massive MIMO to offering ubiquitous and uniform quality of service, then what would be the approach then?
Right. So in this book, he is building a story about why do we have cellular networks, and what are the visions for it, and what is the problem with that vision, and how can one, in a potentially more efficient way, deliver this ubiquitous connectivity in the future. So I have been picking out like 4 topics from the book that are discussed that I thought we could go through in the order of the storyline there as well. So the first one is the question of why do we even have generations in cellular communications?
So why do we have generations? Okay, and what would be the answer?
Well, the first observation he's making is that it is not in all technology areas that we actually have this kind of 10-year cycle generations. And he's claiming then that the reasons are a few different ones, like you need to harmonize the use of spectrum, so therefore you need to put a lot of effort into doing that for every generation. Then you need to focus the research in the world in order to do certain big changes. And then you need to work with compatibility and standardization, and that also something that takes a lot of time. So you need to do this in a generational way. And then you want to create this kind of economical scale of things so that you can, really invest in updating things and building the entire ecosystem around it.
Yeah, I mean, I would partly maybe agree with that, but I would also think, I mean, I could accept the argument with the spectrum that over time new frequency bands are allocated for terrestrial mobile systems. But I would think one of the main reasons for having generations is also not for systems to be backward compatible, I mean, forever back in time, right? So, I mean, you build, for example, 3G and then using a CDMA interface or air interface, and then in 4G, the air interface was built upon OFDMA, so no longer backward compatible. And then 5G isn't a lot different from that perspective, perhaps, but my quick reflection would be that backward compatibility is an important thing that should go into that argument. Do you agree with that? I mean, does the author agree, or take a stand on that?
Yeah, I think that he's recognizing then this point that some changes that can be made are not too hard, so you can keep backward compatibility, but other changes would be more substantial, so you need to throw that away, I guess. So he's elaborating a little bit more and say that if we should need a new generation, there are 4 things that need to be satisfied. So the existing generation doesn't meet future needs, and minor changes would be insufficient to it. So that's sort of a little bit what we talked about. Then,
yeah, but I mean, it's kind of obvious in a way.
Yeah, definitely. Then there should be a consensus of the general approach to meet the needs. So we should be able to focus our research effort onto a limited number of things, so we can really do a difference there. Then the new solution is economically viable for everyone in the value chain, he says, and more spectrum should be needed for more capacity or some other purposes.
Yeah, I mean, not so controversial, really, in my view. I could go along more or less with those statements. What do you think, Emil?
Yeah, I was thinking about other technologies that also work a lot with generations, and there are a number of things. I think for gaming platforms like PlayStations and Nintendo Switch and so on, they work with this kind of maybe 8-year cycles or so you update something and then people can create games for a substantial amount of time, and then you update it again in the future. And there is the nanometer process.
Got another example. Yeah, that's right.
And the nanometer technologies are done, of course, in cycles there as well, where you shrink the sizes, and that requires a lot of effort into doing that. And then you build circuit for a long time on it, and maybe operating systems and computers as well.
Yeah, maybe to some extent. But I mean, operating systems, I don't know if I agree totally, because they tend to be backwards compatible very far back in time, right? I mean, in principle, you could pick up a floppy disk from the 90s and run on the modern Windows, more or less, I suppose. So,
right, but not all computer programs are still working. They need to be updated.
Maybe they need to be updated somewhat.
Yeah, no. So I think all of these 4 things are sort of making sense, that they would be reasons to update to a new generation. I think the thing that Webb is trying to claim is that there is some kind of if and only if kind of mathematical statement here. That is, if any of these conditions are not met, we don't need a new generation, which is somewhat too weird, perhaps. And
that sounds a bit oddball to me. I mean, Sure.
And in particular, then this kind of argument is then made in light of 5G, where he wants to say that most of these requirements, maybe except for more spectrum, were not really met. And he is discussing the new radio, which is the name of the radio interface in 5G, and it says that it was anything but new. 5G adds additional flexibility to the 4G OFDM interface with broader bandwidth and increased number of slot sizes, but makes little fundamental changes. And that this would be an argument for why we actually didn't need it.
Yeah, but I mean, don't you agree with that partly? Because the area interface in 5G is still based on OFDM. I mean, same as in 4G. So what are really the novel elements in 5G? Maybe the insight that reciprocity-based MIMO beamforming in TDD is or scales much better. But
yeah, I think the point then would be, so what do we really mean when it comes from an air interface? Is it only about the multiplexing scheme that we're having? Because then it's, of course, like 2G was TDMA and 3G was CDMA, 4G was OFDMA, and then now if 5G is still that, then nothing is new. But then we know that a lot of things changed, right? In 5G.
5G, I guess, is a combination of OFDM multiple access and SDMA spatial multiple access.
Yeah, exactly.
MIMO. So, but the underlying, I mean, the waveforms on the physical layer aren't they more or less the same in the NR as compared to in the 4G? LTE.
Yeah, in the downlink there are many similarities. In the uplink it was actually changed a bit because it wasn't fully OFDM. But I mean, the point here is that what 5G has been used for so far, I would say, is to boost capacity. So apparently the technology could handle more data traffic using both bigger bandwidth and by using more MIMO, as we were describing. And that is somehow forgotten if one was claiming that, just because it's OFDM, it is still the same as in 4G.
Yeah, well, that's a good point indeed.
Then, of course, there are MIMO features that has also been added into 4G over time, but when you start to change in the control signaling and other parts, which one might view as finer details but are really important in order for MIMO technology to really thrive, then it is a substantial change in terms of end-user performance.
That is true.
Right. So I think one thing that I might be coming back to is also that MIMO is a topic that is close to our hearts, but is not particularly close to the author's heart here, because this is something that's barely mentioned throughout the book.
Oh, really? This is barely mentioned? I mean, but it's such an important technology. I think it's the most important development that's happened in the last maybe, let's say, 15 years, is the introduction of MIMO, particularly in the form of reciprocity-based multi-user MIMO, also known as massive MIMO, which is at the core of the 5G physical layer. I mean, waveforms and all of that are very similar to an LTE, but the embodiment of really true MIMO multiplexing is new.
Yeah.
And that's what also has the greatest potential to boost capacity, which I don't think has been still widely realized. I mean, some year ago, or not that long ago, in fact, I spoke to a representative from a telecoms operator. I think it was at a conference somewhere, and he claimed that, well, we didn't see much of utility from MIMO because most of the time there's just a single user in the cell, and then obviously if you just got a single user to serve at a given point in time, then the spatial multiplexing is of no use.
Right.
But I think find that a very weak argument, because number one, we don't know the reason for why there's only a single user at the time. It could be because of like scheduling or something, that users just aren't, multiplexing isn't harnessed to its full extent. It could also be because of, we just haven't seen the applications yet that require these large area spectral efficiencies.
Right.
But fundamentally, MIMO is the game changer. I mean, more so than more spectrum, I think.
Exactly, and to the extent I've understood, there might be many user devices accessing data at the same time in the cells today, but they are not accessing enough data in order to really require MIMO. So you can, in many situations, just give them different frequencies, and then it will be enough.
Yeah, then it will be enough. I mean, but then the need isn't there yet. I mean, then given the spectrum we have, then if you look at like any given time frequency resource, it's just enough to serve a single user. Okay, so MIMO isn't needed. Yeah. But then the point is that now if we need another 10 times area spectral efficiency, we could multiplex probably 10 users on every such time frequency resource. And that's exactly what MIMO is for and what MIMO does for us.
Yeah, exactly. And I think this is a reason also for why even people who don't work with the physical layer needs to understand a bit of what is going on with the MIMO stuff, because it's kind of different from other kind of resources that we have been using in wireless, like time and frequency, which you can just chop up into pieces and hand them out in the higher layers, and then they are orthogonal resources. But now it's like when there is more demand, you automatically get more resources in the spatial domain when the users are distinguishable there, and that benefit isn't there until the traffic demand is there.
No, it's totally true. I mean, I think we still have an important mission to educate the broader community about the utility of MIMO and what gains it can deliver, and also importantly, when it can deliver those gains. Yeah.
So then the book continues into a somewhat different topic, but still on the same thread here, on things that went wrong with 5G. They're trying to establish the point that 5G didn't live up to its initial visions, and he spent some time describing many of the maybe over-the-top claims that has been made by different people. So, for example, the CEO of Qualcomm said that 5G will have an impact similar to the introduction of electricity or the car.
Oh, wow. But that's obviously an overstatement. I mean, similar to you said introduction of electricity. No, I mean, that I would just cite as an example of bombastic statement that just has very little connection to reality.
Right. And
so here I would agree with the author. I mean, that the marketing was overhyped. If that statement is taken as a representative example of what has been said.
Yeah, and then I think in the beginning of the 5G research era, when people were spending time trying to guess what kind of use cases could at some point in the future be needed so that 5G could potentially support that, then it was things that was maybe purposely quite science fiction, like 3D video, augmented reality, virtual reality glasses, autonomous cars, remote surgery, and these are things that if one viewed them as the real vision that 5G should support these things, and if they are not supported or if this use case doesn't exist, then 5G is a failure. Well then the author is certainly right.
Yeah, that I would probably concur. On the other hand, we don't know about the future. I mean, whatever sounds like science fiction today might become reality in, who knows, maybe 10 years, maybe even less time, right? I mean, this is talking about augmented and virtual reality, and I really don't know. I think it could materialize.
Yeah.
And then whether it'll be like 5G or 6G or some other G that will supply the connectivity. But to me, it sounds like difficult, challenging to build, not obviously useful for humanity. Who knows? Maybe it will be. Maybe it'll be a cool thing to have that the kids want to play with. But it might very well come.
Yeah.
It's not. It doesn't contradict like the physics or in any way really to build this sort of things. No, so time will tell.
Exactly, and the author is arguing here then that either the devices for these services are not good enough, or there is no business cases or demand and so on. But as you were saying, it doesn't mean that it won't happen eventually.
No. That would, I mean, the business case is notoriously difficult to predict, and so that I don't dare to speculate. I mean, devices aren't there, that's true. But on the other hand, I think there is development going on, and who knows? Suddenly, I mean, there'll be the moment where suddenly this technology, capabilities of this technology passes the point where it becomes useful and and ready to be adopted by a wider audience or body of users. We don't know, I think.
Yeah, and it would be kind of weird if there were a company who already have built this very advanced device where the only missing part were the 5G connectivity. And then they had to wait 10 or at least 5 years for the 5G connectivity to be created. So I think the cycle is more like you put a number of research into rooms and projects. They try to brainstorm about what could be potential use cases sometime in the future and break down, okay, what will be the demands for that. Then you set technical requirements for a technology like 5G. Then you standardize it. Then you build the networks, and then you need to see if this device are actually developed and which use cases are actually there, and then build ecosystems around that. So all of these things certainly take a lot of time to actually materialize. And we saw this with video telephony as well, which was meant to be a use case in 3G where you can actually charge per minute for video calls, and very few people use that, but then now people are using it all the time. It just happened maybe 10 or 15 years later than people anticipated.
Yeah, and the question is, that's right. I mean, so it probably happened because of a combination of factors, right? I mean, technology improved to the point that it actually became useful. And I think there was also something like a cultural shift that happened that made people is more prone to adopting it.
Right. Then in this part of the book, there is also a discussion about 5G coverage and it not being particularly good as an argument for why 5G is a failure. How do you feel about your 5G coverage in Lidköping?
Yeah, I mean, I think the question you should be asking is, or the question I want to push back on you is, where's the definition of coverage?
Right.
Is coverage to say that an operator has good coverage, is that to say that the operator covers most of the population, or is it to say that the operator covers most of the area? So do you know, or is there like even a widely adopted or definition in that sense, or does the author of the book here have a definition?
So I think the author here is arguing in a number of different ways. I think we have gone from a point where it was geographical coverage, at least in Sweden, that the regulators were requiring in the 2G, 3G era. If you should buy a spectrum, you need to cover a certain percentage of the land. And then it has been transferred more into population coverage. But then the authors also arguing that in many markets, even if you have quite good population coverage, then the mobile phones are only connected to 5G networks 20% of the time, for example, even if you claim that you have rolled out the 5G network.
Yeah, but 20% is not too bad. I mean, provided that the rest of the time you at least have some basic connectivity. Maybe a few megabits per second so that you can download maybe emails or maps or for some basic browsing on the web. I mean, I don't think most people don't need like high definition video streaming all of the time in real time or services of that sort.
Yeah, so of course, working in the neighboring building to Ericsson's headquarters, I have had 5G coverage around here for a while.
I can imagine. I mean, it'd be strange if not.
But I would say that I've seen over the last 2-3 years how the coverage in Stockholm have been. I mean, if I measure coverage in terms of does it say 5G in the corner of my phone or not, well, then that has been changed from being quite seldom to being almost all the time, maybe with some exceptions when you are indoor or some weird locations.
So what is the answer? I mean, on the question coverage,
right?
Is there was there a clear definition, or is it like up to interpretation what it really means to have 10, 20%? You said, yeah.
So I think the point is that they are building 5G networks around the world at different countries with the population coverage of where they live. Then they want to deliver that to 90-95%. But it is different in different countries how far you have come with that. So I think we have seen this over the last few years in Sweden, how the 5G coverage has becoming closer to this kind of full population coverage, even if you don't have it in the countryside. But when I've discussed this on social media with other people, when I wrote about this on our blog, then I noticed that many other countries might be in situation where we were some 3 years ago, where there is only 5G in the city centers.
Yeah, sure. But that's natural, I think. I mean, you would expect that the rollout of a new generation starts in the big cities and then progressively over time cover more of suburban and eventually rural areas.
Exactly.
So I don't see anything strange there, and I find it a little bit difficult to agree with a claim that 5G would be a failure just because right now coverage is only 20%. And the important thing, again, I think, is that, well, for the remaining 80% of the land or the population, whatever, that they still have connectivity, if not as fast as 5G, but at least a basic connectivity.
Right. And then if one starts to look into the details, and I'm a detailed guy, one can see in the reference list that this 20% number came from 2023. And in a book written from 2024. So it also demonstrates how, if one looks for newer report from the same Open Signal Association, that there will be bigger numbers and the rollouts are actually happening. So it's a bit too early to say what we will converge to in terms of this coverage.
Yeah, I would totally concur on that. I mean, besides these rollouts and adoption rates, they tend to grow almost exponentially over time. So 2 years can make a big difference in that regard.
Right. But I think what would be a more fair point to make is that 5G that we are seeing today is only half of 5G in a way, because we mostly have non-standalone networks where we have 5G base stations, but they are connected to still a legacy 4G core network. And many of these new applications that was not broadband, but ultra-reliable, low-latency communications for connecting self-driving cars, perhaps, or some kind of massive machine type with very energy-efficient connectivity for small IoT devices around the world. These things will not lead to what you have standardized until you also replace the core network with a 5G core network.
I see. So it's not enough to replace the actual radio base stations. You also need to replace all the switching centers and all the other like routers and all the gear that goes into the core network in order to get these low latencies and massive capability.
And there, I think we see this chicken and egg kind of problem that you as an operator need to choose. Do you want to be early with making that switch to a 5G core in hope that you can benefit sometime in the future from these new applications that people envisioned and that people are working on, but is not there right now? Or do you want to wait and only deploy that when you see the possibility of immediately making some more money from it? And maybe that is where 5G is a little bit stepping back and forth, where are we going? But I hear that standalone 5G networks with the 5G core is starting to be rolled out slowly in some countries now, at least.
To be rolled out already, slowly.
Right, but sort of the storyline in the book is then that 5G was a failure. because of this bad coverage. No one wants to really deploy it. They only deploy it at some places, and even then you are only covered 20% of the time and so on. And then what makes it even worse is the 6G visions. And
with the 6G visions.
Yes.
All right. So what are the 6G visions of the author?
Right. So if you search around on the internet, you can find all of these kind of white papers from companies, from academic research centers, and from vendors and so on, who were talking about a few years ago what 6G should be about. And then the whole thing starts over again then with if we were imagining self-driving cars and augmented reality glasses for 5G, what can be even more science fiction like than that?
So what is the answer?
Right. And then there were a number of terms that showed up. People talk about the cyber-physical continuum, where the human world, the physical world, and the digital world are mixed together, and we get this intelligence around us where we can interact with the internet in new ways, and there are these kind of visions.
That's not so clear to me what that concretely means.
No, and in a way, the author is making a case for that there are these kind of visions, the metaverse that Meta was making a thing out that didn't really take off. There is the AI native, whatever that really means, which is often not really defined.
What does it really mean, Emil? AI native?
Yeah, the book doesn't know, but to my understanding, AI native means that you want to change the standard so that you have ways of collecting data in different parts of your equipment, from the radio or from other places, and then move it from these different places to some kind of computing location in your network where you can use it to run AI algorithms.
I see. So basically using these AI algorithms driven by all these sources of data to replace like classical algorithms.
Exactly. And even if the data exists in a 5G or 4G network already in certain places, you don't have the interfaces to move them to one place for training your AI models. And that is then where the AI nativeness comes in. And then one can dream about some other things like the Internet of Senses, where you would be playing maybe computer games with not only hearing and seeing things, but you will also have haptics, so you will feel things and smell and so on.
Haptics is a really cool technology, so I would agree on, or I find that vision somewhat fascinating that you could integrate. Now, to what extent you need all these new gigabits and terabits of 6G, it's not obvious, but haptics in itself, I think, is a cool technology, and maybe in combination with metaverse, and there'll be obviously lots of data generated that has to be transferred over these networks.
Yeah, and I also would like to see this kind of Star Wars-like hologram communication where you can see a person.
So we do a hologram podcast.
Yes, exactly. Help me, Eric Larson, you're my only hope. But then what the author is then making as the story here is that he's taking this quote from white papers and poke a little bit fun of them because of the meanings are not really clear and they are really over the top, and that he calls 6G 5G on steroids because
on steroids. Well, 5G on steroids, is that like we talked the other week about this gigantic MIMO, so would that be like massive MIMO on steroids?
Potentially.
Is that a new MIMO technology on steroids?
In a book where you criticize other people for not defining their big words, then it's not really clearly defined what this would mean either. But I guess it's this kind of thing that you take the technical capabilities of 4G and 5G, which is like a cheat where the numbers are bigger. It's faster, it's lower latencies, and it's more connected devices. And then you just take those numbers and you multiply them with a factor 10 or divide with a factor 10.
Yeah, you just divide by 10, and I mean, you're right. But in a way, I would agree with what sounds like to be the author's standpoint and message here, that there's a lot of like rather fluffy white papers describing all sorts of visions, but not more so than real technological innovation, perhaps. At least so far.
No, so I think that there are all of those visions that are somewhat over the top, visionary, potentially. One could say that this is something that might happen 15 years into the future, maybe towards the end of 6G or even further down the line, but at least it could be leading our thoughts in the right directions. Then I think there are these two parts of it. One, when you develop a new technology, one thing would be that you want to do existing services better, and if better there doesn't mean that people need it to be faster or anything like that, well, then you just deliver more capacity so you can handle more users, and you might be lowering the costs, and that would be beneficial for a telecom operator. But then the other side of this would be that if you build in these new functionalities of different kinds, which might be AI nativeness, which might be that we have sensing and better positioning and these type of things in the network, then we build the sort of first bricks for other people to create new services that hopefully can be monetized and hopefully can bring in new revenue to telecom operators once everyone has a smartphone, which we are almost there now.
Yeah, sure. So
yes, so there are some so there are some valid points here. Then I think what one should bear in mind here is that if you look at the visions more closely, many or maybe all of these people working for companies, academia, or vendors, they are mentioning ubiquitous connectivity as one of the important things. So the ones who really started to define the official visions for 6G is this International Telecommunication Union with their requirements, and they have 6 different main things with 6G, and one of them is called ubiquitous connectivity. So even if one can criticize the relevance of the other 5, it is important to remember that the vision of this book with providing better connectivity, bridging the digital divide, having decent coverage everywhere is already one of the established 6G parts.
One of the established 6G targets, it's already there. I mean, but to me that makes sense somehow, and I think in a way, don't we already have ubiquitous connectivity? Isn't this just a matter of like cost of subscriptions and equipment? I mean, for example, so everybody's got like a cell phone. And then we got sometimes with 5G, sometimes we get only 4G, and who knows, sometimes we got maybe even less earlier generation coverage. Yeah, but then if you get a satellite like Starlink terminal, you get coverage almost everywhere. And if you go on a flight, I mean, I was on a long haul flight last December, and then there was even like Wi-Fi on the plane, and you could even connect to that Wi-Fi for free. You could not use, I mean, you could only use limited services. You could use like WhatsApp messaging worked for free. Not the entire flight, but for much of it. And to me, that is already, I mean, enough in a way. I think that is ubiquitous connectivity to some degree already, isn't it?
Right. So let's go into then the main body of the book here about the ways to deliver this kind of ubiquitous coverage of networks. So he's making this point that there are already networks in a lot of places. And you described some of these things, and if you go to your home and open the list of Wi-Fi, they might be showing 20 different Wi-Fi networks there. There are 4 telecom operators in every country, but you are subscribed to one of them, and you only know the password for one Wi-Fi network, and so on. So he's trying to make the point that if we could just make sure that anyone could connect to any available network, and preferably the best one in terms of being able to deliver the services, we would come very far to delivering this kind of uniform performance already.
But that's, I mean, a statement I would in a way agree with, that there's a lot of connectivity out there that you just can't access because you don't have the right passwords or the right kind of subscriptions. But is that a technological problem, really? I mean, isn't it that if you take up your cell phone and make an emergency call, that it will connect, even though you're like the operator where you have your SIM card and your subscription is out of coverage, but you're within coverage of some other operator, you can still make that emergency call. So this is not a technological problem. It might be a regulatory problem, might be a legal like problem in terms of how the agreements and contracts are written. But to me, it sounds like mostly, it's a softer matter to solve somehow, isn't it?
Yes, I would say that these are definitely important aspects of it, and also the whole thing that we are building, at least for mobile networks, a market with 3-4 different main players who are building networks, and new players can't enter the market because there is no more spectrum, and you need to buy a lot of spectrum. So it's not really a free market, it's more an oligopoly kind of our market. So we are playing this kind of market game as well there, and they of course don't want to open up the networks to the other people's customers except in emergency situations because of business reasons. So business, legal, and policy.
Yeah, legal, business, and regulatory, and policy. That's the word policy, right? So.
But then the issue would be that if you solve those issues, the device still needs to make a decision on what network to use.
Yeah, would it be I suppose it would be the device that would have to make that decision, right? So suppose that you could choose freely, so you got like connectivity to every operator that has coverage where you're located, and you might have like every password to every Wi-Fi network that you're within coverage, or you would be the device would be the one that has to make the decision on which network to access. But I suppose that would be the decision that would have to be made considering cost of the actual access. Because it isn't obvious that it would be the cost would be the same to each of the operators or these Wi-Fi networks. Energy consumption, I suppose, would come in there. Performance guarantees that the respective operator or whatever Wi-Fi network could offer you. But is that really a problem in a way? I mean, I think both you and me could easily come up with like a basic algorithm for making that choice, depending on some basic user preferences. Or where is the issue here?
So the author is arguing that if the device would do it, then it's hard for it to really know what is best for it in a way. So there are so many different ways you can access, and how should it should all the time monitor all of these different ways of doing it. And
I really don't agree with that. I really don't see the problem here. I mean, look, why would that be a hard problem to solve? I think you could train a small little algorithm. This is not like, I mean, it's a choice among a small number of options in the end. And you could train an algorithm to do that based on some user preferences or input that you give it.
Yeah, I don't know it well enough. I know one issue that is happening in practice now, I think, is that mobile phones, they can do Wi-Fi and cellular at the same time, and they can, for example, fill in with cellular when the Wi-Fi is not delivering good enough or not responding. But then many people turn off that feature because having two radio chips turned on simultaneously all the time, even if it helps things to be better, then it is draining a battery.
Oh, it does. Indeed, it drains the battery. And it burns of course, the cellular access burns your quota, your broadband quota, mobile broadband quota. But depending on how much quota you have or what kind of subscription you have, and depending on how much your battery is charged, you can make a decision algorithmically, I think, to what is the best way to connect.
Right. Then one of the core features in the cellular network is that you can call the phone, and the network knows where you are. And the author is making the point that if you can choose what network you're connecting to, well then, how should you be reached?
Yeah, but that, I think that question is rooted in the presumption that reaching, we're talking mobile phones now. Lots of other devices, right? But let's talk mobile phones. So that question seems to be rooted in the idea that a mobile phone can only be pinpointed and reached through its phone number. Whereas a lot of our other services is just totally agnostic to the mode of connectivity.
Yeah. Right. But in any case, the book is arguing that the device wouldn't know what is best for it because it doesn't have enough information. It also argues that you could try to let your telecom operator help you with all of these type of things and collect things, but then it won't know anything specifically about their competing mobile networks as well. So then the main point from the book is that no, you need to create this kind of regional or country by country see what he calls it, a multi-connectivity multi-network controller. That's the name of it.
Multi-network controller.
Yes. So some kind of entity that knows a lot of information about all the cellular networks, that knows about all the Wi-Fi networks and the satellites and everything, and who could tell your device all the time what network to use.
Yeah, obviously one could envision some sort of controller like that, but spontaneously I just feel like it's overcomplicating the solution. But I guess time will tell.
Yeah, and I would guess that the complexity of doing something like that would also be enormous. But it's something that people in academia, or at least in the open literature, are not looking that much into. So one can certainly analyze, would this be a scalable solution, and at what time granularity would you do these type of things, because we know already how hard it is to at the small scale fading time make decisions on things in just one network. So switching back and forth in a very short period of time based on rapid variation of the channels, no, probably we won't do that.
No, that probably would require some significant upgrades to a lot of software, at least out there, right? If you were to roam between different operators on a millisecond time scale.
Right.
True, but I just don't see that. It's not a problem that has the physics against it. In a way, it is just a question of implementing, in fact, software protocols.
Yeah. No, exactly. And on the topic of software protocols, there is also discussion about the fact that when you are handing over a mobile phone from one base station to another one, you still keep your IP address and everything, so that the services thinks that you're still at the same place, so I still have the same connectivity. So you're hiding all of those changes from the TCP/IP. But if you are moving someone from Wi-Fi to cellular or back, then there can be this kind of shorted interruptions, because you get a new IP address and you need to figure out how to route the data in those situations.
But again, this is hardly a fundamental problem. This is a matter of implementing and improving these protocols.
Yeah, exactly.
Yeah.
And the book even mentions there is a quick protocol that was released in 2012 that is already implemented in some web browsers and other situations where you create the end-to-end connectivity contains then a multiplication of different UDP protocols. So you can send through different ways, and if some of those ways are failing, then you fall back on the other one. So you already have this kind of features in some of these protocols. So
it's already
there seem to be this kind
imagine.
of protocols already that, of course, one need to implement in these situations as well.
Yeah, sure. I mean, to me, this is hardly a fundamental or even difficult problem. I think the real question here is like, well, to implement this would require probably a major like software engineering effort, right? To write a lot of code and agreeing on policies and legal terms and business. Like the real question is like, where are the business models who would pay for this eventually, and would anybody really want this so much that it's worth the effort?
Yeah. And there are small examples of this kind of integration already. So if you're an academic, you probably have connected your device to the EduRoam system, which is then connecting your device to any Wi-Fi network that belongs to that organization, which are thousands of them.
Yeah. That's right. Yeah, that's a good example indeed, where you can actually roam with your Wi-Fi.
And I think trains in certain countries, they are connecting the users in the wagons with Wi-Fi, and then they're connecting to cellular networks at the outside, but not just one cellular network. They integrate all of the cellular networks in the country in order to...
They aggregate all the carriers together from all the operators, and then, of course, you boost the coverage. I mean, so...
Yeah, and you could potentially integrate satellites into that as well, for example.
Yeah, you could. Yeah, absolutely. I mean, but again, I mean, to me, that's not a fundamental technological problem. This is a potentially major implementation effort that's required to build it, but definitely can be done.
Yeah, no, I think it's a good point that we should make better use of the connectivity resources we already have there, because there's a lot of things that our devices can't connect to. So if one can solve that in some legal or potential technological way, we should do that.
Yeah, I totally agree with.
But suppose we are solving that issue in one way or another, there will be some coverage holes still.
Yeah, there'll be coverage. I mean, there'll always be coverage holes, right? Again, depending on what we mean by coverage, it might be like holes where you don't get your 100 megabit per second 5G speed. There might also be holes where you just don't get anything, not even simple text message through. And I guess the question is which holes are the important ones to fill here.
And I think the book draws a line somewhere. We should deliver 5 megabits per second to everyone anywhere in the world, and then categorize this into 4 areas where there is still going to be problems, even if you can integrate all the existing networks. And one of these is like urban not spots. So
urban hotspots?
No, not
urban
spots.
Not spot. Is that a new word? I mean, hotspot I think is a very well established word, right, term. But not spot. So November Oscar Tango, not spot. So that means a spot where there is no coverage?
Yeah,
or what does it mean?
Exactly. So if I go down to my basement in the building when they have some kind of emergency rooms down there, there is no coverage. So
that's a not spot then.
And then deploying small cells is the suggested solution to that. So maybe.
Yeah, I guess it sounds to me that some of these not spots might be very difficult to cover from like the outside. And I mean, if you're in like a concrete, like you said, deep somewhere, then
a bunker underneath.
Maybe the only way is to put up a small access point or just a small Wi-Fi router, and you'll be done, I guess.
Yeah, no, exactly. And if it's indoor in your house or somewhere where the business has, there's nothing today that prevents people from deploying a Wi-Fi node there. It's just economics, I suppose, that are against this type of things.
It's just economics, yeah.
then you come to maybe the bigger rural gaps where there no one or very few people live there, so you can ignore those areas and still claim that you have 99% population coverage, and those 1% of people who are living in other parts of the countries or the wilderness where no one lives, how do you cover them?
Yeah.
How would you cover something like that?
Yeah, good question. How to cover like distant rural areas, right? So are we talking about really covering a rural, like think of like a piece of land, just forest, or it could be agricultural land for that matter, or it could be just mountainous or anything uninhabited. I mean, are we talking about really covering such an area, or are we talking about covering like a small village where maybe like 100 people live? Because it sounds to me like if there is some concentration of people there, well, it makes sense to deploy an access point or a base station, right, to make a cell, and then you need a backhauling to that cell. You could either do that through fixed millimeter wave, I guess is the way to go, with a fixed link access from a tower, or you could dig a cable. But if we're really talking about covering vast areas of land where nobody lives really, then that sounds to me to be a more difficult case. I mean, probably satellite would be the only way, the only like really viable way. This seems too expensive to build a cellular network. I mean, granted, we could envision like very tall towers with gigantic MIMO arrays, but you would still need enormous beamforming gains to really, I mean, because the range doesn't scale very favorably with a number of antennas. That's bottom line, right? So even if you get like 1,000 antennas, there are 10,000 antennas there, but still covering a long distance is difficult. You need very large aperture, so you need either really a lot of antennas or a very large wavelength. I mean, a short carrier or a small carrier frequency, or both. In either case, you get very. I mean, in that case, you need a very large aperture, so the thing will be physically very large.
Yeah, exactly.
Yeah, what would be your answer?
No, I think we're coming back there to also regulatory and economics, that we could cover land area to a large extent, at least with deploying more base stations, and they could be taller as well, and they could blast with a lot of power. Then uplink would be the main issue to actually transmit back, I guess.
Uplink will be limited, yeah.
But this doesn't happen because there is no incentive to make money out of it.
No, exactly. That's what I meant. I mean, if you got like a gigantic land area where nobody lives, then it seems like it's just going to be so expensive to build coverage.
Yeah, then there are these sky solutions. So one of them is satellites, of course, and the LEO satellites, who are like 10 kilometers up. So even if they are at the low orbit, they are further away than the International Space Station. But they are... one feature of them is that they are moving around the globe. So if there are some parts of trajectory where there is more people living, then that can in a way pay for that there are other places where there is not much demand, but at least you are delivering some coverage there.
That's right, yeah.
And then the third thing that is also mentioned in the books are this high altitude platform, which is like some kind of balloon that is hanging above an area and cover it from the top.
Yeah, I mean, as an alternative to building a very tall tower, more or less.
Exactly, right? and all of these things are sort of old solutions to an old problem in a way.
Yeah, but hasn't history already delivered the answer here? I mean, because these high altitude platforms were tried. There was this Google Loon project, I think, and it was another one too. But they never succeeded. But eventually Starlink succeeded. with satellites.
Yeah, exactly. So
probably that I mean, that might be. This is speculation. I really don't know, and I'm not sure I should speculate. But I mean, it sounds like that is actually a fairly cost-efficient solution if the goal is to cover very vast areas of land where nobody lives. And the requirements on connectivity are just the basic that no high bit rates or no high multiplexing gains, but just making sure that no matter where you are, you can at least get some basic connectivity to your network.
Yeah, no, so there's definitely interesting things happening there, both with Starlink and with competing systems that are a little bit behind perhaps, but if we will have that different options there, and your mobile phones or other devices could connect also directly to them, which is something that is turned on. I think the latest iPhones can connect in some part of the world to satellites, but only when they lack other coverage. Then they are trying out also with Starlink to direct to device kind of connectivity, and there's a lot of research also trying to integrate this into 6G so that the same 6G ships could also be directly connecting this, so you don't need to have multiple radios for connecting to satellites as well.
Right. I mean, it would be truly interesting to know more about the fundamental limits of satellite communication. For example, is there a limit to how many small satellites that we could launch into orbit? I mean, on the LEO, into LEO orbits. And is there a fundamental limit on the cost of actually launching them there? And how long will they live? What happens when they go out of service? I mean, will they continue to circulate around? Can we shoot them down or decommission them in some other way, or just burn? I mean, shoot them down meaning burning them in within orbit.
Yeah, I think one can.
I don't think I have a good appreciation for what the limits are, and if there are limits, I'm sure there are some limits. How far away from those limits we are, right? I mean, for terrestrial communications, we kind of know what the fundamental limits are, but for satellite, at least I don't know. So that would be an interesting thing to figure out more about.
Yeah, I think that the new satellites that are not so expensive to launch and to build compared to the old ones, they also don't have very long lifetime as well. So I think they have a system for decommissioning them, but I don't know in the details in my head. But it's just an interesting thing, and satellites is of course traditionally meant for providing good coverage, but not necessarily deliver the capacity that people are needing. And the book is also discussing a little bit about that the existing spectrum for satellites might not be sufficient to satisfy everyone's need in the countryside if a lot of devices can connect.
Again, I mean, that's a regulatory question in the first place, I would think, not so much as a fundamental question of what is actually viable to do. Yeah. Okay. Maybe we are digressing from.
No, I think one of the argument also, because William Webb is someone who's been working with spectrum policies, was describing the possibility that if you are in regions where we know that there is no cellular coverage, then in those regions you can potentially let the satellites reuse ground spectrum as well.
Absolutely.
And that could potentially help out as well.
Yeah, of course, that would probably make the satellites more complicated to implement, because they would have to be like multi-band and adapt themselves. And so you need like a lot of filters, I suppose, and RF components that could adapt.
So this is also one of the more interesting parts of the book, where you go through different scenarios where you still would have to deploy more infrastructure of one kind or another, and discuss the different options and have some opinions about what would be the most preferable one. But these are also the parts that are worth reading, I think.
So do we approach the end now?
Yeah, I think that we are.
We are? Okay. Yeah. So what do you think? Where's the punchline? And is this a book that is this a recommended read? Or we said at the beginning there are categories of books. The ones that help you fall asleep, and the ones that help you stay up all night. So which one would you place the 6G manifesto into?
Right. So the book is 150 pages long, and I think out of them, it is particularly some 30, 40 pages that are the most interesting ones to read. I think that this vision for ubiquitous connectivity and delivering 5 megabits or whatever number it would be everywhere, and the ways of doing that is important things to people to learn about. And I've been talking about these visions for a number of years myself, but then my solution have always in my talks converged into cell-free massive MIMO as a way of sort of dealing with interference. And this book is taking a different view from the whole thing about the integrations of the resource that we already have, and that makes good sense, and then discuss what we can fill in with. And even if it doesn't mention MIMO almost at all, so cell-free massive MIMO is also not part of delivering more capacity where that is a limiting factor, then it still mentions the important thing.
It doesn't have to be cell-free, right? Even just MIMO properly used is really the tool for improving area spectral efficiency.
Right. But I think that for people who are in the area, this could be a good vision for actually finding some new research directions as well to solve some of the parts here, be it some kind of mix between technology and economics, or some scalability or algorithmic or protocol developments that would have to be made. I think the issue with the book is that in order to promote this vision, sometimes the book is also going very hard against things that they claim is the predominant view of things. So it's like they pick the sort of most futuristic visions from everyone in the world and try to bash them, and then they forget about mentioning that connectivity for everyone is also one of the things that everyone agrees upon. Ericsson calls this limitless connectivity, for example. They've been talking about for years. And they are making the point that just because the 5G new services haven't taken off yet, that will never happen. And for that reason, the only thing we need to do now is to consolidate, provide more stable coverage, and then we are done. That is sort of the argumentation. And that is a very pessimistic view of things. Potentially it's right. I don't think that it's right. I think there are still more devices that will appear that will generate more traffic, whether they will need other kinds of connectivities than mobile broadband. That's a different story, I guess. And then, MIMO is generally forgotten in the book. So when it talks about that division of 10 times higher data speeds in 6G, then it says, well, the only way of delivering that is to have 10 times more spectrum, and 10 times more spectrum we can only find in terahertz.
Yeah, I mean, just to be clear, that's plainly wrong.
Exactly.
So, but I think that summarizes well. I mean, and to me it seems like we still have a mission to educate the community about what MIMO really is for, and how spatial multiplexing, even at a massive scale, is the game changer to provide area spectral efficiency. And to some extent, I mean, ubiquitous coverage. We talk distributed cell-free MIMO, they can really provide this ubiquitous coverage. But talking spectral efficiency, I think just regular, conventional, co-located massive MIMO is enough.
Yeah, definitely that is a solution for the cities of the world, and then maybe the other solution we talked about will be more cost efficient or better for other parts of the world, where it's not interference that is the limiting factor, but just the lack of decent connectivity at all.
Great. All right. So, thank you, Emil.
Thank you very much. And for those who would like to dig in a bit more into this, there is a book review on our blog, Wireless Future, where there's also some links to other content. And of course, one can buy this book rather cheaply in the Kindle version as well.
The Kindle version, yeah. All right, super. Okay, so thank you so much, Emil.
Thank you.
And to our listeners, don't forget to like and subscribe to us on YouTube.